Hey class, and welcome to this little quick video on how we think about takeoffs for framing. So framing really unlocks how you construct the structure. It talks about walls, roofs, floors, and knowing how these walls are constructed is a big part of figuring out how much things cost. We learn about how they're insulated, how they're clad. So the floor plans are a great place to start when you're doing framing takeoffs. And there are two things we use to do takeoffs for framing. We use linear feet for things like walls. We use linear feet for things like interior partitions. And we also use things like area for figuring out what the area of the floor plate is or the roof assembly. And that helps us figure out things like the amount of sheathing we need, adhesive to adhere that sheathing down to the floor joist. In this case, I've got an engineered TGI. And then based on the area, divided by 16-foot centers, how many TGIs I need to make that floor. So let's kind of go through some of my work here. So before you got here, what I've done is I've worked around my perimeter of my structure, measuring to the exterior, and I've taken all those dimensions, with a 3/8 scale. I used my red dot little trick. I scaled what the length of that wall was from sheathing to sheathing, because that's how long my plate will run. And I've written those dimensions down. So 28, 14, 28, 14. My second floor has a cantilever. So I've scaled that and realized that that is 30 feet long upstairs, 14, 14, 30 feet. So those are my linear takeoffs for walls. The next thing I did is I grabbed my red pen and I looked at my interior partitions. So in this case, I have a couple types. I've got P1 and I have P3. And I worked around with my scale again. Grab my red little trick here. And if I scale 3 feet, I wrote 3 feet. 3 feet, wrote 3 feet. Scale the partition, I got 27. So every time I'm scaling something, I'm leaving that dimension along that wall so I never have to scale it again when it comes down to recording in my estimate sheet. It's always on the page. Coming upstairs, again, same thing. Scaled all my partitions. Left all the notes there. So that allows me now to summarize how many linear feet of, P1 I have, P3 I have, and then do some costing. The next thing I did just to finish my takeoffs was I also have, aside from walls and floor, I have some structural things. So I took my orange marker, which is just my little structural note. So I took orange, and any note that's structural, I circled in orange. So I've got a nice little handy framing schedule down here. It shows me that I've got both floor joists, I've got some beams, I've got posts, and I've got lintels. So I worked around and I circled all the lintels. So I've got L2 and I've got L2 in the rear. I also got some posts, so I circled those. I came down to the first floor and I work around the perimeter. So I've got B1, P1, P1, B1, L2, B1, 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 and L1. So next thing I did is I figure out, what's the linear length of B1 I have? Because I'm going to buy that B material by linear feet. So I grabbed my red pen, grabbed my scale, and I simply scaled all the lintels, all the beams on each floor. Wrote those down. So if it's pointing at B1, I read, in this case, 10'6", point at B1. Same thing for B1 back here, L2, etc. So now I'm ready to sum those. The last thing I have is I have posts. So I have posts here and there on the second floor. So you can do almost everything you need from one plan or the floor plan for framing takeoffs. But what you don't know is for this 30-foot long wall, divide by 16 inches to figure out how many studs you need. You can calculate linear feet of plate. But what you don't know is what length of stud do you need? And when you have the length of the wall, what's the height of the wall to give you the area of the sheathing? So what we use for that is we use our sections. So we flip to our section drawings, and for me that's on A2.0, and I can take my scale, of my outside wall and say on the main floor, from the base, top of the foundation wall to bottom of that plate, I have a 7-foot stud. So I can use 8-foot studs for that. Upstairs, 7 feet again. I can use 8 foot for that. On the exterior of that second floor, because I've got this 2% slope, I have to use a 10-foot stud. And on the same side back here, I can use an 8-foot stud. So if I take those dimensions back, I can relate those back to my plan to say my first floor up here, this is 8 feet throughout. So 8 feet tall throughout. And back here, I've got 8 feet on the low side. But back here, because I've got this 2% slope, I've got to use a 10-foot stud. So this is 10 foot tall. This is 10 foot tall. And this is 10 foot tall. So when I'm listing my different walls to calculate linear lengths, I've got to take into account the height. So main floor here, I've got 28, 28, 14, and 14. They're all 8 feet, and I'm going to record them by their wall type. So W1 up top, I have 28 feet. So at 8 feet tall, I have 28 feet of that wall type. W1A, which is it's a fire rated assembly, I've also got 28 feet. W2 is my end walls, and it's 14, 14. Guess what? It's also 28. P1, I've got a partition here. I've only got 3 feet of that wall. That's also 8 feet because it's all on the main floor. P3, I've got 27 feet and 3 feet. That's 30 feet total. Also 8 feet. Upstairs, it's a bit of a different story because I'm working with both an 8-foot wall and I've got 10 foot because I've got this 2% slope on my roof. You know, that you can see if I flip my elevation here for you. I can show you that I start at 8 feet down here, but I grow up to 10 feet. So it's important to note 8 feet here, 10 feet, and 10 feet. So I've got W1 in the back. I'm going to record it by length. So 30 feet at 8 feet tall. So W1, 8 feet, 30 feet. W1 at 10 feet, I've got 20. And that is plus this by the back, I've got 30 more, so I've got 50. 50 feet there. P1, I can add up all my partitions. So I've got 2, this is 12, 18.5, 22.5, 33, 41.5, and 47.5. So 47.5. And then P4, I've got this shallow little knee wall around the stair. I've got 10.5 and 13, so I have 13.5. So all linear lengths. If I want to remind myself, you know, I can write ln.ft. So that's linear feet. I can say that's throughout. Okay, so all my framing takeoffs are by linear foot. Now I want to get the area of my second floor plate. So I can confirm in my floor schedule what is constructed from. And because I'm platform framing, which I can confirm with a section, you know, I frame the first floor walls and my perimeter of my rim joist and sheathing goes right to the outside of that wall. So I want to do my takeoff for my second floor plate right to the extent of the sheathing, not to the inside of that wall. So what I do typically is I grab my handy dandy square. I go corner to corner. I've already done this, but I'll do it again. I go right to the sheathing and I go all the way through. I do the same thing on that side. And always leave your marks, your lines on the page. And it's going to remind you where you took those sheathing lines from. So I go side to side. And I want to figure out, well, how much sheathing do I need? So it's 30 times 14. Multiply that together. I get 420. And I leave my math right in the center. So 420 square. So for F2, I have 420 square feet. So when I get to sheathing and joists, I can calculate that. The next thing I do in this plan is I look at my things like my beams. So I've gone through I've measured everything. I've taken all the lengths and I've added them up. So B1, I took all my beams from the second floor and I have 58.5 feet. My posts, I took my 1, 2, 3, 4. I went to my section. I confirmed they're 8 feet tall. So I have 4 at 8 feet. And I took my lintels, same thing, listed them down. So all my framing takeoffs are basically complete for my walls, floor, posts, beams, and lintels. The last thing I have to do is my roof. And the best place to do that is on the roof plan itself. So same thing, I would take my line, I'd mark corner to corner because I want to know sheathing area for the roof. In this case, when I did this earlier, I got 458.5 square. Now the thing you need to keep in mind with roofs is on any pitched area, the dimensions you're seeing here is the orthographic dimension. It's what it looks like by looking at the plan straight down. So if I take this square, let's say this is 12 inches. If I tip this up towards the camera that you're seeing overhead right now, this looks a lot smaller. It probably looks like it's only 6 inches long. And that's because you're seeing the orthographic projection of that slope. If I flip it flat again, you see it's much bigger. So this roof is on a 2% slope. So the dimensions you're seeing is the orthographic dimension. It's looking straight down. You need to know if you laid that roof flat, because you have to sheathe the roof flat, how much air do you need? So I take my 458 and I have to figure out how much do I add to this to take into account that roof slope. So I look at things like my slope here, which is 2 inches to 1 foot, which is a 212 roof. I look up my roof factor and I'd multiply 458.5 by whatever my roof factor is. So I looked it up online, I get an equals, and I get the actual area. And that's the actual area that I take into account. So you always want to take into account that roof slope. If it's a 112 pitch, I believe the multiplier is 1.0035. If you had a 1212 pitch, so very steep, you'd multiply the orthographic area by the roof factor for 112, which is 1.4142. So almost 1.5 times the orthographic projection is what you need for area. So you look up 2%, whatever slope you have, look up the roof factor and multiply that factor by the orthographic area. And that's going to be my area for, in this case, my R1 assembly. So once I get that done, I'm basically done my framing takeoffs. And I can start to break down what each wall is. So W1 having plates, studs, sheathing, nails, adhesive, sheathing tape for air barrier. Break that all down in my estimate, but it's all from this quantities. So walls, linear feet, floors, area, roof, area. And structural, we're going linear feet as well. So beams, lintels, and posts. Hope that's helpful. Have fun. Breaking down framing is really exciting because you're to learn how the structure is built. And once you get a head around it, it can be quite an enjoyable thing to do. Okay, have fun.